All right, so this whole thing is about applying what you just learned with the Pythagorean theorem, only going the opposite direction. So in the previous section, the whole thing was about us being given a Pythagorean theorem problem where they tell you that there's a right angle in it, okay, a 90-degree angle. Okay, you would notify that by having a little red square that says it. Well, that's not always going to be true, okay? In some situations, you might have all the numbers, and you have to figure out whether it is going to be able to be used Pythagorean theorem, if you're going to be able to use Pythagorean theorem or not. So, for instance, this problem says the converse of Pythagorean theorem is if the equation a squared plus b squared is equal to c squared. So if you plug in the dimension they give you, and it actually works, then you know for a fact it's a right triangle. Except before, it was a right triangle, so use Pythagorean theorem. Now we're using Pythagorean theorem to prove that it's a right triangle. We're going both ways. Okay. Another example to look at before I go into the notes is this distance formula. Okay. Now, technically, you do not need to memorize this. Let me be very specific. You do not need to memorize it. There it is. Okay. You do not need to memorize it because it is the Pythagorean theorem. Okay. You'll see in your textbooks, especially as you get to the upper school, they'll say memorize your distance formula. You can, but as long as you understand all it's asking you to do, when it's saying do the square root, I mean, you have all those squares, you guys know when you solve the problem, you have to do the square to solve it. So they're doing everything ahead of time. Okay? So you notice in this triangle right here, you'll notice that you have a leg here, let's say leg A, and you have a leg B, and then this is still your hypotenuse. The hypotenuse is going to be your answer. And to prove that, okay, a squared plus b squared equals c squared, think about what you have to do in this problem. In order to solve for hypotenuse, you have to do the square root of this side, or you got to do it to the other side. So this is equal to c is equal to the square root of a squared. Well, look at a. If I said this leg a, it's the difference of these 2 points. Well, what do you notice over here in this formula? It's the same thing. Okay? So your a squared is actually x to the x sub 2 minus x sub 1, and then squared. You got to maintain the same things. Plus the difference of the 2 y points of the b leg. So that'd be y sub 2 minus y sub 1 all squared. So do you have to memorize the distance formula? No. If you just have memorized the Pythagorean theorem already, which I think most of y'all have already, right? You're going to use it so much. That's all you have to really know. Okay? So that's just so you know where it came from. The distance formula came from Pythagorean theorem. All right, so look at some examples. Tell whether each triangle is a right triangle. Okay? We don't know, but we can use Pythagorean theorem to figure it out. So write your formula. A squared plus b squared equals c squared. Your 2 legs are 9 and 40 because the longest side is always going to be your hypotenuse, your c. Plug them in. Then go ahead and simplify and solve. You notice you're trying to figure out, are they equal? Because if they're equal, then you know it's a right triangle. 81 plus 1600, does it work out? Yes, then you can say for sure it is a right triangle. Okay? Same with the other one. Longest side is 24, that has to be your hypotenuse. Okay? Don't look at the picture just because it looks like it's more than 90. Don't pay attention to that. Okay? Most things are not drawn to scale. They're going to try to play with you a little bit. All right? Plug in your formula. A squared plus b squared equals c squared, and plug in your numbers. Okay? When you go through mathematically, is 144 plus 324, 576. Hard to see 4 and 4 is 8, so it's going to be no. It's not going to be equal to each other. Therefore, all we say is it's not a right triangle. Okay? As for another one, find the distance between these 2 points. Now, it's easier to draw these out, would be the easiest thing, but we just really got to find out the difference between the 2 x's and the distance between the 2 y's. Okay? So the first thing we're going to do is what are the 2 x's? X1 and Y1 of the first point is a 1, 5, and the point number 2 is -4, -2 over here. Okay? So plug in your values from there. Okay? Simplify and solve inside the parentheses, and then go from there. Ends up being square root of 74 as your answer. Okay? Which you can go through that and go a little farther in depth, which estimate what numbers 8 times 8 is 64, and 9 times 9 is 81. So what would be the approximate distance of this? somewhere 8.5, we'll say. Okay, we'll say approximately. Just have an idea. You should be able to approximate your square roots. Okay, but that's okay for that point. Could you simplify it more? Yes, but we're not to that point yet. All right. Notice how I plug numbers in. If you wanted to just do a visual, I know a lot of you are visual people. You could have done 1, 5, and done a point up here, 2.1, and then you could have done -4, -2 here. So that was 0.2. Okay, and just did a distance between those 2 points. Well, if you know your point from, is that 1 to a -4, the distance of that is 5, and then from -2 to a +5, so 7. You could have done that way and got the same exact answer either way. Okay, whatever one you feel more comfortable with, you can do. All right, last one for my football players. Okay, yeah, now you all pay attention, right? You design a football play in which a player runs down the field, makes a 90-degree turn, okay, and runs to the corner of the end zone. Okay, your friend runs the play as shown. Did your friend make a 90-degree turn? Each unit of the grid represents 10 feet. Okay, so look at this picture. This is the starting point. Your buddy took off from line of scrimmage, took off this way, and then doing a little corner route right there, right? Is that the proper name for it? Corner route? Okay, little corner route there. Did he do a 90-degree turn? So we have to first find out the distance between this point, these 2 points, then find the distance over to this point, and then we can find the distance of this point here. And if it equals our Pythagorean theorem, then we know for a fact we did it correctly, right? So what is the first thing we need to do is find out the distance between these 2 points. Okay, so they said each box is worth 10, right? Each side of it's 10. So let's do your first buddy's route, the first one. So that's a what? 30 by 30 triangle, right? So do first piece, a squared plus b squared equals, so it'd be 30 times 30. We need y'all's help if they do these fast. 30 times 30 is 900 plus 900 c squared. And what's the square root of 1800? 1800 is 42. We're just we'll keep it as this for now. Just know that's 42.42. It keeps going on. Might have an answer later on. We got that piece. Now we do this next piece from here to here. How far is that? This corner out. So from here to down here is how many? 10, 20, 30, 40, 50 by what? 1, 2, 3, 4, 50. 50 by 50, right? So do our formula. A squared plus b squared equals c squared. 50 squared plus 50 squared equals c squared. 50 times 50? 2,500 plus 2,500 is 5,000. Okay.
But doesn't he stop once he crosses the end zone?
The throw comes when he gets to the corner.
Sorry?
The guy who's running.
What are you talking about?
Doesn't he stop whenever he crosses the end zone?
Not if he has a collar.
He's going to the corner. He's going to the corner. The
Oh,
throw.
okay, wow.
Okay. So the c is equal to square root of 5,000, which for our numbers
Doesn't say that.
ends up being approximately 70.71. Now, here's what you got to think about. The last piece is the hypotenuse right here, the little squiggly line here. We have 1, we have 2, we're trying to figure out 3. Did he make a 90-degree turn? If he did make a 90-degree turn, a squared plus b squared has to equal c squared. We have to find c squared and we're done. And then if they all match up, we're good to go there. Okay. So what is the points from here to here? Well, from here is how many total yards? So 50, 60, 70, 80 all the way down here. That's 80. And how far over is that? 20. 80 plus 20 squared equals c squared. 8 times 8 is 64. 20 times 20 is 400. Is 6,800 is equal to c squared, and then the square root of it. So c is equal to 6,800. Okay. So we have all our different lengths. So you can technically plug them in. A is equal to square root of.
I'm confused on why you did the first one with green.
Alright, let me finish and then we'll go into it. A is what? 8 squared 1800? Correct? Next one is square root of 5,000. What do you notice about something that's being square rooted and you're going to square? What's going to happen? It's going to go, the square root's going to go away, right? So anything that, if you're squaring a square root, remember the square root is 1/2 power times the square, so it ends up being canceled out. So then all we're left with is what? 1,800 plus 5,000. Is that equal to 6,800? Yes. So what can we do about this answer to the question? Did our friend make a 90-degree turn? Yes. So all that to say, yes, he made a 90-degree turn.
A lot of words, he made a 90-degree turn. But how do you know that?
Very sharp.
How do you know? Here, let me stop, pause the video, and then explain.